In this podcast episode, Stuart Hameroff, an anesthesiologist with decades of experience, delves into the mysteries of consciousness, anesthesia, and what science might be misunderstanding about death. The conversation spans topics ranging from the microtubule theory of consciousness and quantum mechanics to near-death experiences, psychedelic states, and the potential for novel therapies like ultrasound for Alzheimer's. Hameroff provides personal insights, critiques mainstream neuroscience, and explores the intersections of physics, biology, and parapsychology. Stuart Hameroff's journey began in the 1960s as an undergraduate fascinated by consciousness. Though he initially considered neurology and psychiatry, he chose anesthesia for lifestyle reasons, inspired by his mentor, who suggested that understanding anesthesia is key to understanding consciousness. During cancer research, Hameroff became intrigued by microtubules, tiny protein structures inside cells that pull chromosomes apart during mitosis. Unlike his colleagues focused on chromosomes and genes, he saw microtubules as potentially housing a form of intelligence or proto-consciousness. He learned that anesthetics operate by depolymerizing these microtubules rather than acting solely at neuronal membrane receptors, challenging the mainstream view that anesthesia works by blocking synaptic transmission. Hameroff highlights how excessive anesthesia breaks down microtubules, inducing unconsciousness despite preserved neural activity measured by evoked potentials and EEG, indicating that traditional membrane-level explanations of anesthesia do not fully capture its influence on consciousness. Anesthesia remains poorly understood, even after its discovery in the 1800s with ether and nitrous oxide, agents that induce unconsciousness while allowing the brain to remain physiologically active. Hameroff explains that, unlike sleep, anesthetized patients do not respond to painful stimuli and experience a total loss of consciousness. Intriguingly, time does not seem to pass during anesthesia. Patients often report waking up instantly without perceiving intervals of unconsciousness. Hameroff touches on rare cases of intraoperative awareness, often attributed to human or technical errors, underscoring the delicate balance anesthesiologists maintain. He contrasts anesthesia's irreversible unconscious state with sleep's reversibility, where external stimuli can awaken one. The conversation also touches on memory erasure theories, but concludes that since consciousness itself cannot be conclusively measured, assumptions remain speculative. Central to Hameroff's theory is that consciousness arises not from neuron-membrane interactions, but from quantum processes within microtubules. He critiques the traditional neuroscientific standpoint that equates neurons to simple binary bits in a large-scale computation, arguing that even single-celled organisms exhibit intelligent behavior enabled by microtubule structures. Hameroff presents the idea that each neuron contains about 1 billion tubulin proteins capable of oscillating at megahertz frequencies, far exceeding computational capacity estimates based solely on synaptic activity. He credits physicist Roger Penrose for providing a quantum mechanical framework to understanding consciousness through an objective reduction model wherein quantum superpositions in microtubules collapse at thresholds defined by space-time geometry, producing moments of conscious experience. This approach attempts to unify quantum mechanics' measurement problem with consciousness, proposing that collapse is spontaneous and fundamental rather than observer-induced or reliant on many worlds' interpretations. Hameroff elaborates on the quantum measurement problem and Penrose's use of general relativity to explain how superpositions cause instability in space-time curvature, leading to wave function collapse and conscious moments. This theory avoids the infinite branching of universes and the need for a conscious observer causing collapse by positing an objective threshold determined by space-time geometry. Although initially met with skepticism and ridicule by some mainstream scientists and philosophers, the theory remains a unique attempt to ground consciousness in fundamental physics, positioning it as intrinsic and fundamental to the universe alongside mass and charge. When asked about simulation theory, the idea that reality is a computer simulation, Hameroff dismisses it as a cop-out that fails to explain consciousness itself. He argues that consciousness must be understood in physical terms before entertaining notions that it arises from or exists within a simulation. Taken as a default position by some, He likens it to believing the moon is made of green cheese until proven otherwise, and emphasizes the necessity of grounding explanations in empirical science. Hameroff's post-retirement research plunge involves astrobiology, particularly the study of organic molecules returned by the NASA OSIRIS-REx mission from the near-Earth asteroid Bennu. These samples revealed sugars, amino acids, and even cellular-like structures containing aromatic rings associated with quantum optical effects. Hameroff and colleagues hypothesized that these aromatic quantum oscillations might signify primitive life or proto-consciousness and seek to test if anesthetics inhibit these oscillations similarly to their action on microtubules in neurons. This line of research extends to the concept of time crystals, dynamic, repeating oscillations postulated to be fundamental to life and consciousness, potentially present in microtubules and other organic systems. Challenging anthropocentric views, Hameroff argues that plants and single-celled organisms possess microtubules and may exhibit minimal forms of consciousness, albeit at much slower rates than humans due to lower oscillation frequencies. Experiments show that anesthetics inhibit plant movements like sunflower turning and Venus flytrap reactions, further supporting the notion that microtubules could be a universal substrate for consciousness in living beings. Hameroff acknowledges ridicule for these views, yet contends that intelligence and proto-conscious qualities emerge from microtubular activity, not solely from neural networks. Hameroff criticizes mainstream neuroscience for ignoring the intracellular complexity of neurons, focusing instead on cartoon models that reduce brain function to simplistic algorithms of integrate and fire neurons. The dominant model attributes consciousness to emergent computation across neural networks, but Hameroff argues this neglects the quantum and subcellular scale where true conscious processes may reside. He is skeptical of AI consciousness claims, questioning how computation alone, requiring vast amounts of energy and fundamentally classical machinery, could replicate human conscious experience. AI, he says, may simulate consciousness convincingly, passing Turing tests, but that doesn't imply genuine sentient awareness. Hameroff shares his belief in consciousness surviving bodily death, describing how brain activity during near-death experiences, NDEs, and cardiac arrest shows transient surges of synchronized gamma oscillations even after the EEG appears flat. These neural correlates may underpin the vivid, serene, and often transformative experiences reported by survivors. He separates hypoxia-induced confusion from the calmness of NDEs and suggests consciousness exists fundamentally within space-time geometry, potentially able to leak or remain distributed holographically in the universe after physical death. Personal stories from patients and documented studies support this view, including evidence for reincarnation from children's past life memories with matching birthmarks or trauma. Hameroff proposes dreams as quantum logical states where superpositions remain uncollapsed, producing experiences disconnected from classical reality. Psychedelic substances such as psilocybin and DMT may shift consciousness to higher frequency oscillations, expanding non-local and potentially quantum aspects of awareness, akin to NDEs. Preliminary studies measuring brain oscillations during DMT experiences suggest enhanced quantum coherence and frequency dynamics. He also discusses the brain filter hypothesis, suggesting the brain filters vast quantum or universal information to manageable conscious experience, making psychedelic states a temporary lifting of that filter. Contradicting standard theories, localizing memory storage at synapses, which turn over quickly, Hameroff argues that the durability and complexity of memory require a substrate like microtubules inside neurons. Microtubular tubulins exhibit vast combinatorial possibilities to encode and preserve long-term memory holographically throughout the brain. Anecdotal transplant cases where recipients acquire donor traits or preferences bolster microtubules' role beyond the brain, especially considering the heart's extensive microtubule-rich nervous tissue. Inspired by microtubule oscillations in the MHz range, Hameroff hypothesized that low-intensity, unfocused ultrasound could stimulate microtubules non-invasively and safely. Early personal trials produced feelings of creativity, euphoria, and cognitive clarity. Subsequent clinical studies on chronic pain patients showed mood improvements, and emerging evidence suggests low-intensity ultrasound may improve cognitive function and reverse cortical atrophy in Alzheimer's patients by promoting microtubule repolymerization and synaptic restoration. Unlike focused, high-intensity ultrasound used for blood-brain barrier opening or lesioning, low-level ultrasound is inexpensive, portable, and widely accessible. Despite promising results, institutional inertia and pharmaceutical interests have stalled broader adoption. Hameroff underscores the safety and therapeutic potential of this modality, including its distinction from controversial electromagnetic exposures like 5G or microwave Havana syndrome, which may disrupt microtubules deleteriously. Hameroff embraces parapsychological phenomena, such as ESP, telepathy, precognition, and even certain aspects of UFO research, as plausible within a framework of quantum non-local consciousness. He references institutions like the California Institute for Human Sciences and IONS, which support scientific investigation into these phenomena, and acknowledges both authentic demonstrations and fraudulent cases. Hameroff discusses telepathy experiments, including telepathy tapes, involving autistic children reportedly communicating non-verbally. He also highlights the need for rigorous controls and skepticism, such as employing magicians to detect trickery. The involvement of government agencies like the CIA in researching and sometimes infiltrating such domains reflects ongoing interest in weaponizing or understanding consciousness-related abilities. The conversation touches on plasmoids or ball lightning, plasma or corona discharge phenomena seen in UFO and atmospheric observations, with surprising intelligent behaviors like play and movement without recognizable propulsion. Hameroff speculates these may manipulate space-time curvature to move arbitrarily, possibly linking them to consciousness through gravitational interactions as suggested in quantum gravity theories. He recounts personal sightings and collaborators' research about these formations, pondering their place in the broader context of conscious phenomena and unexplained aerial phenomena. Hameroff criticizes the dominant Alzheimer's drug development focus on amyloid plaques, which correlate poorly with dementia severity, and contrasts this with evidence implicating tau protein tangles and microtubule destabilization as more direct causes of cognitive decline. He relates debilitating experiences from scientific skepticism and potential suppression of microtubule stabilizing drugs like ipothalone B, which have shown promise but are overshadowed by expensive, often ineffective anti-amyloid therapies. Hameroff advocates for renewed investigation into microtubule-targeted treatments and low-intensity ultrasound as safe approaches to support neuronal structure and improve cognition. In experimental studies using rats and corona photography, Kirlian photography, Hameroff demonstrates that anesthesia suppresses corona discharge patterns associated with consciousness, implying these are connected to electron mobility or ionic activity disrupted by anesthetics. This effect similarly applies to plasmoids and may provide a physical link between anesthetic mechanisms and the manifestation of conscious phenomena via electromagnetic fields. These findings support the idea that consciousness has measurable corollaries in biological and perhaps environmental electromagnetic signatures. Hameroff has organized the Science of Consciousness Conference since 1994, highlighting efforts to unify empirical, theoretical, and speculative approaches to understanding consciousness. He plans to retire from organizing the event, but continues to pursue practical applications such as ultrasound therapy for cognitive decline and further exploration of quantum biology. The conference promotes interdisciplinary dialogue addressing core challenges in neuroscience, quantum physics, parapsychology, and artificial intelligence, aiming to push forward understanding where mainstream models falter.